So welcome back, friends. We can continue by looking at the divisions, types or categories of centrifugation. Centrifugation. So centrifugation can be divided into two broad types, namely preparative sense and analytical centrifugation. And mostly analytical centrifugation is related to as analytical ultracentrifugation. Why? Because mostly the types of centrifuges used in analytical centrifugation are ultracentrifuges. So we can come to preparative centrifugation. This preparative centrifugation can further be divided into differential and density gradients centrifugation. This density gradient centrifugation can also be further subdivided into rate zonal and isopycnic. So this is the breakdown, how you can break this down from preparative divided to differential and density gradient. This density gradient subdivided into rate zonal and isopycnic, and whatever we've explained here can also apply there, just there in these steps. So we can start looking at this preparative centrifugation. What is preparative centrifugation? Just from the word itself, preparative, you can see that there is preparation of something. So preparative centrifugation involves the preparation of a certain component or mixture or anything for further analysis. So in preparative centrifugation, both the process and the product are important. In preparative, both the process of centrifugation and the final end product result that we get is important. Why? Because we're observing the process that is taking place and everything, but again, after we get a product, we can subject it for further analysis. That's why it's called preparative centrifugation. So in preparative centrifugation, there are two types, namely differential and density gradient. So with differential, the first one, differential, what we can explain here is first we know what the basic components of centrifugation are. You get the tube, you put in the sample to be separated, then you subject it to centrifugation. But with differential centrifugation, it is you subject your liquid medium to multiple processes of centrifugation with increasing rotor speed. So if we have a cell homogenate, there, we'll subject it one to multiple processes of centrifugation. So what will happen is that we can subject this cell homogenate to, let's say, 10,000 G or 10,000 at a speed of 10,000 RPM, or let's just say 10,000 G for 10 minutes. What will happen is that based on SSD, size, density, and shape, there are some particles of the cell that will settle at the bottom as pellets. And most likely the heavier phase in the first centrifugation of a cell homogenate is nucleic acids are part of that. So you have nucleic acids settling at the bottom, and you have your ribosomes, your lysosomes, and peroxisomes settling at on the surface as the supernatant. Then again, you get the supernatant, pour in another tube, subject it to further centrifugation, but at a higher speed, and you increase the time. So maybe let's say 25,000 G. Then you have again other cell components settling there, and you have others on top as a supernatant. Then you run the process again. So it's just subjecting a certain component such as cell homogenate to multiple processes of centrifugation at increasing rotor speeds. That is differential centrifugation. That's just the basic principle behind it. Then with density gradient, it's a bit different. With density gradient, you have a prepared density medium. You have maybe the increasing density from the top to the bottom. So you have maybe lesser density, and it's increasing as you go to the bottom. So when you put in your sample of interest, you have separation taking place due to size, density, and shape. But this same density, this GC, density gradient centrifugation, is further subdivided into rate zonal and isopycnic. So with the rate zonal and isopycnic, let me just do them simultaneously. Isopycnic. So the difference is that in rate zonal, the medium of separation is already prepared. The gradient medium is already prepared. So what you have is, maybe you have a gradient already prepared of sucrose solution with increasing density from top to bottom. And then you get your sample of interest and place it there on top. Then subject it to centrifugation. And after centrifugation, what you will have is that this is entirely based on size. The separation is entirely based on size. So you have components actually sedimenting based on their size. You have larger components at the bottom there because they are denser, and you have maybe less dense components as a supernatant there on top. Then those which are maybe there on the middle will settle on the middle. So you have different bands forming, or zones. That's why it's called rate zonal. You have zones forming at different locations. But with isopycnic, the difference is that unlike here where the density gradient is already prepared, in here you have the separation medium, selected separation medium, such as cesium chloride, being uniformly placed together with the sample of interest. So you have it like that. In here you have the separation medium and the sample of interest. Then you subject it to centrifugation, and the end result will be that that selected medium that you had chosen when the centrifugation process takes place, what happens is that it forms zones of densities. So it forms zones of densities, and then the separation in this isopycnic is entirely based on density. So size is not there to be considered. So what happens is that you have particles settling at places where their densities correspond to the density of the medium. So if large components are corresponding to the density which is here in the middle, then they'll settle there. They'll form bands there. If you have smaller components corresponding density to the density of the bottom part, then they'll form bands there. If you have maybe this type of components corresponding there, then you have that there. So this is entirely based on density rather than based on size. So these are the types of divisions in the preparative centrifugation. But just know that after preparative centrifugation, you can get the sample of interest, the supernatant, and further subjected to analysis, further analysis. So the last part is analytical centrifugation. Analytical itself shows that you are analyzing something, you're observing changes and everything. So in analytical, what's most important is the process rather than the result or anything. So you have the process being the most important thing here. Then another thing we can say here is that since it's analytical, there's an optical device placed in the rotor chambers so that the analysis is taken as the process is taking place. So analysis is taken as the same process of centrifugation is taking place, and ultracentrifuges are used in this type of analytical centrifugation. Then you have measurements of physical quantities such as molecular weight, density, purity, conformational changes, and the likes in analytical centrifugation. So that's the basic principle of centrifugation. If you like this, please subscribe.